In this video, we are going to use our knowledge of z-scores and probability to find an x value. So, the average on the last test was a 72.5 with a standard deviation of 6.8. So let's go ahead and put that into symbols. Mu is 72.5, sigma is 6.8. So we have a mean and we have a standard deviation. Stacy claims she scored better than 90% of her classmates. So if I would draw my normal distribution curve, according to Stacy, if this is Stacy here, she scored better than 90%. So that means 90% of her classmates are over here. So for this to be true, what is the lowest possible test score for Stacy? So that's what we're trying to find. What is this x value? Well, if you know that this is 90%, we know that the normal distribution table gives us area to the left. So if I go to my table and I look inside at all the probabilities, I'm going to find where 90%, so 0.90, closest to, and we find an approximate z-score of 1.28. So that would be the z-score for this line. But that doesn't tell me the lowest possible test score. The test score represents x, right, my data value. So if I recall, my z-score is found by taking x minus mu over sigma. And I can now use my data that I just had. So recall, I've got these values. Let's go ahead and plug them in. So a z-score of 1.28 is my data point minus my mean of 72.5 divided by my standard deviation of 6.8. And now it becomes an algebra problem, multiplication. So I'm going to multiply both sides by 6.8 because these cancel out, right? It's like multiplying fractions. So I'm left with x minus 72.5 equaling 8.704. My last step to get x by itself is to add 72.5 to both sides. Again, these inverse operations will cancel each other out, and our x value then gives me a value of 81.204. So the lowest possible score Stacy could have had is an 81.2, and if she scored better than 90% of her classmates.